Are you looking for a school that nurtures your child's academic, spiritual, and personal growth? Andalusia Academy International School, where your child's future is our priority. We offer comprehensive education levels, kindergarten, Pearson I Primary Certificate, secondary and Pearson IGCSE certificates.
We are a school that emphasizes in the Deen and Dunya. It's integrated in that on the side of Islamic studies, we have Quran, we have Hadith, we have Arabic. And then of course in the secular side, we have all the subjects.
We focus on student-centered learning, where we engage our students in different levels. Other than that, we have very innovative teachers who help to cultivate creative thinking, problem solving, which are very, very key skills in our learners, not only in school, but also for their future.
Hello everyone, my name is Aisha Mohammed and I'm a student under Andalusia International School. I've been here for the past 5 years and I'm in year 11 right now, and my experience in this school so far has been amazing.
Admissions are available. Visit us today. We are located in Nairobi, South Sea, Andalusia Academy International School, where your child's future is our priority.
Welcome back again to today's session. My name is Teacher Kasim. I'm a teacher of Maths and Chemistry and I teach at Andalusia Girls. Smart Learning with Andalusia Academy on Horizon TV. So last time we had a chapter on organic chemistry. We did some various subtopics, and as you're all aware, this is a kind of a huge chapter that has roughly around 8 subtopics. So last time we captured 2 parts of the subtopics. That is on the part on the introduction, which was well captured. Then we captured the part on the alkanes. So today we shall narrow down our discussion to the other subtopics that are left, and we shall begin with the crude oil part, which was not captured in our last discussion. So we shall say that the crude oil is actually a mixture of different hydrocarbons. And from our last session that we had, we defined hydrocarbons as organic compounds, or rather that contains carbon and hydrogen as the only elements. So you cannot say that alcohols are hydrocarbons, but alkanes and alkenes are hydrocarbons. So we shall also narrow down our discussion to the crude oil as a mixture of different hydrocarbons. Also, we shall discuss about the process of the extraction, or the process of the manufacture of the different fractions that are found in the crude oil. We shall also name these different fractions depending on the size of the hydrocarbon chain, because we have them ranging from the ones that have short hydrocarbon chain to the ones that have a long hydrocarbon chain. So that is on the process of the extraction, and then we shall discuss about the part on the fuel. So we shall say that a mixture of hydrocarbons, basically, which includes the alkanes, and alkenes. And I think now we can go to the process of manufacture of different fractions. Process of manufacture of different fractions. And the fractions in the crude oil are around 6 fractions. We have the refinery gases, we have the gasoline, we have the kerosene, we have the diesel, fuel oil, and the bitumen. These fractions are collected depending on the size of the hydrocarbon chain. For example, the refinery gases is collected at the top, whereby the temperature on the chamber of distillation is a bit low. Why? Because the refinery gases has a short hydrocarbon chain. Bitumen is collected at the bottom of the tower, the distillation tower, because it has a very long hydrocarbon chain. So the fractions are collected depending on the size of the hydrocarbon chain. So on the process part, I will say that the fractions are collected depending on the size of hydrocarbon chain. The short hydrocarbon chain the short-chained hydrocarbons are collected at the top of the tower, while the ones with long chain are collected at the bottom of the tower. The points where the fractions are collected depends on the size of hydrocarbon chain. Also depends on the melting and boiling point. You'll find that at the top of the tower, the temperatures are a bit low, while at the bottom of the tower, temperatures are a bit higher. That's why the hydrocarbons that have short hydrocarbon chain will always be collected at the top of the tower where we have low temperatures. But the ones that have a long hydrocarbon chain will be collected at the bottom of the tower where we have high temperatures. So I'll proceed and show you the structure, the chamber, how it looks like, the one that is used in the extraction of these fractions from the crude oil. So we have the heater at this part. So the crude oil is injected first in the heater. So this is actually the heater. So here you inject the crude oil. Then we have this chamber that has different compartments. At the top, we are able to collect the refinery gases. The refinery gases are collected there at the top. Then closely, we collect the gasoline. Then we collect the kerosene. Collect the kerosene there. Then we end up collecting the diesel. And then we end up collecting the fuel oil. And then the last part to be collected in the tower is actually the bitumen. So these are different fractions that are collected from the crude oil. We have the first part being the refinery gases. Temperatures here are ranging from the 40 degrees Celsius, and down here is maybe roughly 1000 degrees Celsius. So you can see in this tower, we have low temperatures at the top, meaning that the fraction that will be collected at the top must always have a short hydrocarbon chain. Fractions collected at the bottom must always have a longer hydrocarbon chain. And these are the fractions that have been extracted from the crude oil. So it is a process, it's a long process that involves the crude oil being injected in the heater. So here, the crude oil is actually heated at a very high temperature. So these fractions, they vaporize depending on their melting and boiling point. The ones that have a short hydrocarbon chain will always be collected at the top of the tower, and they include the refinery gases, gasoline, and kerosene. But the ones that have a long hydrocarbon chain, they must always have a high melting and boiling point, and they'll be collected at the bottom of the chamber. So this is what you call the fractional distillation tower, the chamber for the extraction of different fractions from the crude oil. Now, I will narrow down our discussion. This is all what you need to learn about the crude oil. So the next part is on the uses of the fractions that are obtained from the crude oil. Of course, these fractions that have been collected here, they have different uses. So I will narrow down our discussion now to the uses of different fractions obtained from the crude oil. So on the uses of fractions. So the first fraction is refinery gases. On the uses of these fractions, you have to be to the point or be on the point on the uses of these fractions. The first one is refinery gases used for domestic heating. The second part is on the gasoline. This is now actually the fuel fuel for cars. Gasoline is a fuel for cars. Then we have kerosene. Kerosene is used as actually the fuel for jets. Is a fuel for jets. Kerosene is a fuel for jets. Then we have diesel. We have diesel is fuel for heavy machines. Fuel for heavy machines. Fuel for heavy machines. Then we have the fuel oil. Fuel oil is actually the fuel for ships. Fuel for ships. Then also we have the bitumen used in road surfacing. Used in road surfacing. So these are different uses of different fractions obtained from the crude oil, ranging from these gases, the refinery gases, and we are saying that they are basically used for the domestic heating and also cooking. And they include things to do with the methane. Methane falls under the category of refinery gases. We also have ethane. Actually, these are the shorter chain hydrocarbons that are used for the domestic heating and cooking. So we have the gasoline. Gasoline is actually the fuel for small cars. And also we have the kerosene as a fuel for jets. We also have the diesel as a fuel for heavy machines. And we also have the fuel oil as a fuel for ships. Then we have the bitumen that is basically used in the road constructions. So I think that is all we need to know and understand on the part of the crude oil. Then now that part on the crude oil is done, we need to go to a different subtopic, and that is basically on the alkenes, because we have captured the crude oil. So our next subtopic is on alkenes. There's a big difference between the alkanes and the alkenes. Alkanes last time, from our last topic, we said that the alkanes, these are hydrocarbons that have single covalent bonds between the atoms. Alkenes have general formula CnH2n+2. We also said that alkenes are referred to as saturated hydrocarbons. We also said that the alkenes can be burned in oxygen to form water and carbon dioxide. That is when it is the excess supply of oxygen. We also talked about alkenes and said that the alkenes have a single covalent bond between the atoms. The name of the alkenes ends with N. The name of the alkenes ends with in. So there's a lot of a difference between these different homologous series of the hydrocarbons. So for the alkenes, we shall narrow down our discussion to the introduction part of this. So the general formula, they have general formula CnH2n. They have names ending with in. They have names ending with in. They are unsaturated. They are unsaturated hydrocarbons. They are unsaturated hydrocarbons. And this is a part of the alkenes. So when they have carbon-carbon double. They have carbon-carbon double bond. So the feature that differentiates alkenes from alkanes is the fact that the alkenes have a double covalent bond, but alkanes have single covalent bond between the atoms. So that is the part of the alkene. So we go straight to the issue to do with the displayed formula of the alkenes. So on this part, I'll break it down in two steps. First, I'll go to the nomenclature. On the nomenclature is actually the naming of different alkenes, because the way we name alkanes is not the same way that we name alkenes. they have different naming. But if you understood the idea of naming of alkanes, it will be easier for you to understand the naming of the alkenes. So, steps. Of course, there are steps in naming of the alkenes. The first step is identifying the longest carbon chain. Identify the longest carbon chain. Identifying the longest carbon chain. Carbon chain. When you identify the longest carbon chain, how important is that? It helps you understand the parent name of a different or a certain alkene. So helps you to identify the parent name. Helps in identifying the parent name. Helps in identifying the parent name. So once you identify the parent name, what's the next part you do? The next part is you number the carbon atom from the side of the hydrocarbon chain that gives the double bond least numerical value. So you number the hydrocarbon chain, from the side that gives the bond least numerical value. So you must always number from the side that gives the bond least numerical value. What do I mean? I'll give you an example. If you have this hydrocarbon chain that has 4 carbon atoms, let's say 5 carbon atoms actually. So, and you have, this is the first one, this is the first, and you have another one, second, that also has 5 carbon atoms, but a different location of the double bond. So when it comes to naming, look at the parent name, the hydrocarbon chain. These ones, they all have 5 carbon atoms. But how do you number? You must number from the side that gives the double bond, the carbon that has double bond, the least numerical value. For the first one, numbering must begin from the side. So you must number this as carbon number 1, carbon number 2, number 3, number 4, and number 5. But you cannot number this as number 1, number 2, number 3, 4, and 5. You cannot do that. For the second one, numbering has to begin also from the side. So that this is a carbon number 1, number 2, number 3, number 4, and number 5. The third one, I can give you also the third hydrocarbon chain that still has 5 carbon atoms, but different locations of the double bond. So when you look at the second one, numbering must begin from this side. So you number it as carbon number 1, number 2, number 3, number 4, number 5. What am I trying to put across? The carbon number 1 gives a carbon that is in first contact with the double bond least numerical value. So carbon number 1. The second chain, or the hydrocarbon chain, gives carbon number 2 the carbon atom that bears the double bond least numerical value. So here is carbon number 1, here is carbon number 2. But this third parent hydrocarbon chain, we have to number from the right, moving towards the left, because carbon number 2 is the one that is in close contact with the double bond. So that is on the steps in naming of the alkenes. The third step, identify the branched. You must identify the branch chains. Sometimes they are called side chains. Identify the side chains and their names. E.g., we can have a methyl side chain. That's a methyl. We can have a chloro side chain. We can have a bromo side chain, and so on and so forth. So that is the different steps that are very important when it comes to naming of different alkenes. So I'll go to examples. I'll give you the first example on the naming of these alkenes. So example 1. I'll give different examples on the naming. So example 1. I'll give the easiest first. As we said last time in our last lesson, every carbon atom must have 4 covalent bonds. That's the first compound. Second compound is the chain has 4 covalent bonds. So the first thing on the naming is we say that we must follow the rules. The rules are very clear. Identify the longest carbon chain, the parent name. So the first one, we can number the carbon atoms from whichever side, doesn't matter. We can number the carbon atoms from whichever side. Why? Because the double bond is at the middle of the carbon atoms. Double bond is at the middle of carbon atoms. So we can number the carbon chain from whichever side. So we can decide to have carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So from this, the parent name must be a bute. 1, 2, 3, 4. 4 carbon atoms. So the parent name must be a bute. Then the ending must be an "-ine" because they are alkenes. But also, you must always mention the carbon atom that is in first contact with the double bond. So in this case, in the first one, is carbon number 2. So we shall have the name as, the name becomes a bute 2-ine. This name is much more better than butene. Butene is kind of wrong because you don't specify, you must specify the carbon atom that is in first contact with the double bond. But in the second one, it's not specified. So this one is better answer than this answer. The next one, we have to start first by identifying the longest carbon chain. How do we number the carbon atoms? Do we begin from the right or from the left? So again, we must begin from the left because here we have 4 carbon atoms and the carbon number 1, this is the carbon atom that is in contact with the double bond. Carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So the parent name is a bute. It must end with an "-ine" because they are alkenes. So the name here becomes a bute 1-ine. Becomes a bute 1-ine. This is a better answer than butene. So that is on naming of the straight chains, straight chained alkenes, straight chained endocarbons. So let me go now and give an example on the branch chain endocarbons or branch chain alkenes. So let's see how we name this compound. As 5 carbons, 1, 2, 3, 4, 5. And there is a double bond in between. Then there's a side chain there. Then we have hydrogen, 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 and hydrogen. These are different endocarbons. These are different alkene because it has a branching. It's branched. So if it's branched, the naming is a bit different. So the steps follow. We follow the steps. The first step is identifying the longest carbon chain. So on this one, this one is our last compound to be named. So we must number from this side: 1, carbon number 2, number 3, number 4, and number 5. So at carbon number 2, we have a branch chain. So it's a 2-methyl, 1, 2, 3, 4, 5, pent, 2-methyl pent, 2, pent 2-ine. So that is it on the naming of endocarbons. And I think from our next lesson, we shall continue from different chapter subtopics on the organic chemistry. That is on the alcohols. We go to the esters, we go to the polymers, and also we wind up with the part on the carboxylic acid. Thank you so much for your time. Until next time, thank you so much.
Ooh.